Law of cosines is a very, very important law. It is a formula that lets you solve triangles, which means find all missing parts, missing sides and angles, and they don't have to be right triangles, which is new. We've done some trig, but we've always had right triangles. This is going to completely expand the world of triangles that you can solve. What do you think about that, JoJo?
That's pretty amazing.
It is very amazing, JoJo. So let's get to it, the law of cosines. And rather than me just throwing down a formula and you copying it down, let's sort of see where it comes from, how we use right triangles, and extend our brain knowledge to non-right triangles. So I'm going to start by making this little altitude. An altitude is kind of like the height. It goes at a right angle from one vertex to the opposite side. Now I'm going to label some sides. So first of all, this red altitude that I just drew, if you were to use your right triangle trig, that would be 18 times the sine of 30 degrees. Let's kind of write it across the middle there. 18 sine 30, because remember, you would go sine of 30 equals this side over 18, then you multiply by 18, like so. This one down here, similarly, from here over, would be 18 cosine 30. Think about those if you're not convinced. I think you can convince yourself. Now, usually we'll call, in this case, the 30, usually we will call that side A if it's across from angle A. And actually, let me go back and adjust these. I want a generic formula, not specific to this triangle. So I'm going to call this one B sine C. I'm going to call this bottom one the 18 cosine 30. That's going to be B cosine C. Now, if the entire side down here is A, then this portion right here is going to be A minus B cosine C. Okay, so what we're going to do now is a Pythagorean theorem that says C squared is equal to B sine C squared plus A minus B cosine C all squared. All right, so that's the Pythagorean theorem on this triangle right here. All right, I'm keeping it generic with A's, B's, and C's. I'm deriving the formula. Now, let's simplify that a bit. C squared equals B squared sine squared C. When you want to write sine of C all squared, you put the squared after the sine because you don't want to confuse it with the sine of C squared. Now over here, we're going to have to FOIL. We're going to have to get A squared minus 2AB cosine C plus B squared cosine squared C. All right, I had to write that A minus B cosine C twice and FOIL it, multiply it all out. Do not distribute the squared to both parts. So now if we clean this up a little bit, what I want to do is take this term and this term, and I want to group them together and factor out B squared. And I'm left with sine squared C plus cosine squared C plus A squared, which is here, minus 2AB cosine C. Now here's a rule. Depending on the order in which you're learning your trig, there's a rule called a Pythagorean identity that says that sine squared of anything plus cosine squared of that same thing equals 1. So this is basically gone. And what we end up with a little bit of rearranging, A squared plus B squared minus 2AB cosine big C. Little a, b, and c are the side lengths. Big C is the angle. And this is the law of cosines. All right, this is what you need to have definitely written down and you need to remember. What this will do is it involves all three sides and one of the angles. So if you have side, 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 you can find an angle. If you have side, angle, side, you can find the missing side. And really, if you look at it, the Pythagorean theorem is just one special case of the law of cosines. Because what happens if C is 90 degrees? Well, the cosine of 90 degrees is 0, which means that part just wipes out and you're left with the Pythagorean theorem. Now, again, depending on the order in which you're learning your trig, some of this might be future stuff, but I didn't want to just throw down a formula. I'd like to discuss where it comes from when possible. Now, make sure you have that written down. I'm going to get that out of the way, and we're going to actually solve this problem. All right, so let's take this, put it up here, and solve some questions here. Okay, what I have is the 18, the 30, and the 30 side length. I've got side, angle, side. And I'm trying to find AB. So that can be, you could call that side little c. You could call it AB. Doesn't really matter. I'll put a little c there so that it corresponds to the Pythagorean theorem. Now, what do I know? I'm looking for c squared. I don't know that. What I do know, side A is 30. Side B is 18. Minus 2 times 30 times 18 times the cosine of 30 degrees. It's that easy to use the law of cosines once you have determined what's little a, b, and c, and big A, B, and C. All right, the law of cosines is set up perfectly for a side, angle, side to find the side opposite the given angle. All right, so I'm going to pause for a second, get out the calculator, and solve this thing. Okay, so here's that expression typed in. This would be what c squared equals. So I'm going to hit enter there and get 288. Now that's not the side length, that's the side length squared. I'm going to square root that and get 16.99. So we'll just call that 17. All right, and always check, is it reasonable? If that's 18 and that's 30, is it reasonable that that's 17? Yeah, it is. All right, so what you've done is you've found missing parts of a non-right triangle. It's important, very important in our study of trigonometry. All right, so let's look at a different scenario. Using the law of cosines to find a missing angle. In this case, C is what we're looking for. Now, first of all, the A, B, and the C, those are arbitrary, meaning it doesn't matter what letters you use. All right, my letters on my original triangle could have been rearranged. They could have been X, Y, and Z. It does not matter. The thing that matters is that this angle here corresponds to this side here. The very first and the very last thing you write are a side and its corresponding angle. And when I say that, I mean the one that's across from it. It has the same name. So let's set this up. If I'm looking for angle C, the only angle in the whole setup is the very last thing that you write. So what I know is this. Let me start that over. I'm realizing this is going to be a two-stepper. So what needs to happen is I need to find side B and then use the law of cosines again to get angle C. So let me start over. What I know right now is that B squared equals 10 squared plus 22 squared minus 2 times 10 times 22 times the cosine of 84 degrees. Okay, the side, the B and the 84 are the corresponding, that's the very first and the very last thing I write, and then the other two sides just go in place. All right, so again, I'm going to pause and calculate and see what we get. Okay, so here is that info plugged in. So B squared is 538. The square root of that is 23.2, we'll say. All right, so now I know 23.2. Now I'm looking for an angle. I'm looking for angle C. If this is the case, if I'm going to find angle C, then the first thing I need to write is the 10, because the 10 corresponds to the C. So 10 squared equals 22 squared plus 23.2 squared minus 2 times 22 times 23.2 is the cosine of C. Again, that C corresponds to that 10 because that 10 is across from that C. All right, the other two side links that are not the first and last, regardless of letters, go here and get squared, go here and get squared, and then go here and here. Does not matter. I think one of the things that causes people grief on this is the getting hung up on the A's, B's, and C's. So don't even worry about what letters what. All right, so now how am I going to solve this one? Well, let's see. Calculator up. I'm going to start with 10 squared. Then I'm going to subtract 22 squared to move this term over. Then I'm going to subtract 23.2 squared. So now this negative 922.224 is equal to all of this. So I'm going to divide by negative 2 times 22 times 23.2. And so now what I get will be equal to cosine of C. And remember, if you know what the cosine equals and you need to get the angle, you inverse cosine that result. And I get 25.4 degrees. And it's kind of a small angle. It makes sense. It looks like about the right amount of degrees. Now, I know I didn't show every single step on the algebra, but if you're not comfortable, just write out all the steps. Just subtracted, divided, and then inverse cosined it. Make sure you're able to get through those steps. So I didn't want to show them all for the sake of time. Last case, side, side, side. I'm giving them all. And I'm asked for angle T. This one's going to be a one step because I have all the sides that I need. So what I need to do is make sure that if I'm looking for angle T, that's the last thing I write. And I need to start with the 28 because that corresponds. So I get 28 squared plus 23 squared plus 21 squared minus 2 times 23 times 21 times cosine of T. And now we're in the same situation for solving that we were just a minute ago. All right, so if that last one went a little too fast, you can follow along on this one. 28 squared. All right, and when I'm doing my steps of algebra, what I'm going to do is subtract the 23 squared and the 21 squared. I'm just going to go along and hit enter all along the way. Now, negative 186, I'll add in an extra step this time. Negative 186 that I got from subtracting equals the rest of this. So I'm going to divide both sides of the equation by all three of these numbers. And in my calculator, I need to be sure that when I divide, I either divide them and hit enter separately, or I divide by parentheses negative 2 times 23 times 21. Otherwise, your calculator is going to divide by the first one and then multiply by the rest of them. Cosine and sine are never bigger than 1, so you're always going to get an answer at this point that's smaller than 1, and then you're going to inverse cosine to get the angle. I get 78.9 degrees. So, big ideas from this video. Don't get hung up on A, B, and C. It does not matter what the letters are. Memorize this formula, but realize the side length that's on the left all by itself must be across from the angle that's on the right at the very end. And other than that, don't really forget about the letters, but the letters are insignificant. They could be named anything. So we'll use it to find side lengths, like in number 1. Use it to find angles. Sometimes you have to do 2 steps, like in number 2. And then this one, just 1 step. Make sure you choose the right side lengths in the right places. So that's it. That's the law of cosines. The amount of triangles you can now solve has multiplied by a lot. I'm pretty pumped about it. How do you feel about it, JoJo?
I feel great.
He feels great. Young and JoJo out.